Hi, this is Professor Jones bringing section 1.5 to you, quadratic equations. The objectives for this section are to solve quadratic equations by factoring, by using the square root property, by completing the square, and by use of the quadratic formula. We also want you to learn to use the discriminant to determine the number and type of solutions that a quadratic equation may possess, as well as determining the most efficient method to use when solving a quadratic equation. We'll also take a look at solving problems that are modeled by quadratic equations. Let's start by defining a quadratic equation. A quadratic equation in X is an equation that can be written in the general form ax squared plus bx plus c equals 0. A, b, and c are real numbers with a not equal to 0. So a quadratic equation in X is also called a second-degree polynomial equation in X. One of the things that can be used to solve these equations when factoring is the method used to solve is the zero product principle. And this principle states that if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. So looking at it symbolically, it basically says if a times b is 0, then a is 0 or b is 0. So when you solve a quadratic equation by factoring, if necessary, rewrite the equation in the general form ax squared plus bx plus c equals 0. Factor completely. Apply the zero product principle, which means that you'll set each factor containing a variable equal to 0. Solve the equations that result in step 3, and you can always check the solutions in the original equation. Another method for solving quadratic equations is the square root property. Now this property involves equations that have the form u squared equals to d, where u is an algebraic expression and d is some non-zero real number. The square root property actually says that u squared equal d has exactly two solutions. Either u equals the square root of d, or u equals the square root of d times -1, or negative square root of d. A more concise way to say this is that if u squared equals d, then u equals plus or minus the square root of d. And notice this is exactly equivalent to what was stated above. Solving a quadratic equation by completing the square is a process that manipulates the equation so that it is in a form where you can use the square root property. So the first step is to take your equation, whatever form it's been presented in, and writing it as a squared plus bx equals -c. Remember that a will not equal to 0. So if a is different from 1, divide each term by a, and you'll obtain x squared plus b over a times x equals -c over a. By adding on the constant b over 2a squared to both sides of the equation, the left side becomes a perfect square trinomial, which can be factored, and you can now solve the equation using the square root property. The quadratic formula results if your quadratic equation ax squared plus bx plus c equals 0, with a not equal to 0, is solved using the process of completing the square. We find that a pattern emerges where the values of x, which solve the equation, depend only on the constants a, b, and c. This pattern is described in the quadratic formula, which states that x is negative b plus or minus the square root of b squared minus 4ac all over the quantity 2a. So this formula, you may have often wondered, well, where does this formula come from? It comes from starting with this equation, ax squared plus bx plus c equals 0, and completing the square. So the quadratic formula is the pattern that always results when you complete the square on a quadratic equation. The discriminant is the portion of the quadratic equation ax squared plus bx plus c equals 0 that results when you apply the quadratic formula to this equation, and the discriminant is the portion of the quadratic formula that is underneath the radical. So it's actually the quantity b squared minus 4ac, which allows us to determine the number and types of solutions that the equation will have. So if we just look at the value b squared minus 4ac, we will know how many and what type of solutions the original equation has. If the discriminant is positive, there will be two unequal real solutions to the equation. If the discriminant is 0, there is one real repeated, often called a repeated solution. And if the discriminant is negative, there are two imaginary solutions. So section 1.5 covers these topics, and there will be additional videos available that give examples of the ideals discussed in this video.